Hi, everyone. So as promised, we've done equations with word problems, inequalities with word problems, and now we're going to be doing proportions with word problems. Now, the proportions that we're looking at, a real application of this is percentages. So we have three objectives today. Understand percentage relationships and how they could be represented as a proportion. Learn what percentage increase versus decrease actually means, and then also determine a few methods of how to solve these types of questions. There's many, and I'm not going to cover all of them. What matters is that you show work to support how you answered the questions. So, without further ado, let's go on to our do now. So, again, as I've been doing, I'm writing in the time. So for this, you're going to take no more than 5 minutes. And the question is, which team improved the most? You should have 2 to 3 sentences to support this. Don't just say, oh, the football team, oh, the basketball team. You have to support it somehow with work. So 5 minutes, which team improved the most? So the first thing that we might notice is all the teams improved by 8 points. So at first we might say, wait, which one improved the most? Well, the football team, and so I'm going to label them A, B, C for my work. So the football team improved 8 points compared to 22. I'm going to write that as a ratio, 8 compared to 22. B, basketball team improved 8 compared to 100. And C, the baseball team improved 8 points compared to 4. Now notice I have to use the same structure for all of them if I'm trying to compare. You could have done it in a different way, but they must use the same structure. Now, I'm going to turn this into percentages. So this 8 divided by 22 is 0.36 repeating. This is 0.08, and this is 2. To get from decimals to then percentages, I multiply by 100. So this is a 36.36 repeating percent. This is a 8%, and this is a 200%. So which team improved the most? Well, the baseball team, a 200% increase. So here is our first example. I'm going to take us through this. Now, again, there's many ways to go about solving this. A cereal box says that now it contains 20% more. Originally, it came with 18.5 ounces of cereal. Now, I'm going to take a look at this, and I'm going to use a diagram. So this is representing my original. So this is my 100%. And that is 18.5 ounces. Ounces is abbreviated with OZ. Now, I'm then going to increase it because it says 20% more. So 20% more. And I'm going to think to myself, well, what's 20%? Well, that's 1/5. So there's different ways about going about this, but we can use a ratio. We could say that since 100% is equivalent to 18.5, I need to get to 20%, which is dividing by 5. Therefore, I divide this side by 5 as well. And when I do that, I get 3.7. So therefore, 20% is 3.7. You could have actually also done it a different way. You could have found the unit rate. So this goes back to our unit rates. I could have said 1%, divide by 100. So divide by 100, and therefore I would have gotten 0.185. And then multiply by 20, which gets me to 20%. Multiply this by 20, and I again get 3.7. So how much comes in the box? Well, it's the 100% plus the 20% as my diagram shows, which is therefore 18.5 plus 3.7, and therefore that's a 22.2 ounces. This is how much is now in the box. Now, pay close attention to what I'm about to say. This 20% I would call the percent increase. I increased 20%. The 22.2, this represents the percent compared to the original. What is this percentage now? It's 120% because it's the 100% and the 20%. So here is a key takeaway, and then we're going to do another example. When dealing with percentages, we write our new percentage as a comparison to the initial amount. Our initial is 100%. Now, what we also have to discuss is when we're dealing with percentage increase or decrease, and I'm just caring about that part. Now, we just did what's called a percent increase because it went up. Now we're going to do a percent decrease. Now, in this situation, we then again have the price of a shirt is $18.50. So that is my 100%, and it's $18.50. Now, in this case, instead of building onto the box, I'm going to actually break my box into fifths, because this is my 20%, which I'm now losing. Well, this is the same problem as before, so I don't have to calculate 20% again. 20% of 1850 is 3.70. But in this case, we're losing as percent decrease. So I'm going to say 1850 minus 3.70, and this ends up equaling a 14.80. This is my new price after the discount. And if we're losing, remember this is 100% minus my 20%. So this therefore equals 80% of the original. So it's a 20% decrease, which results in 80% of the original. So here is a practice problem for you. Again, notice that I want you to take no more than 4 minutes. You're writing each percent increase or decrease as a percentage of the initial amount. Pay close attention to that vocabulary. Percentage increase or decrease, percentage of the initial amount. Those are two separate things. We're going between them. All right, give it a shot. So I've written boxes to represent my 100%. So question 1, 40% more. Well, that's a 40% increase, which means when I write it as an initial amount, it's 140%, the original amount. Now I have 25% fewer sunny days. So here's 25%, and I'm losing this from 100%, which means it's 75% of the original. Compared to last month, there was a 50% increase. Okay, there's my increase of 50%, which means I have 150% the original. The runner's time to complete the marathon was 10% less. So I'm losing 10%. Well, that means I have 90% of the original. Let's go on to the next practice problem. There's 2 diagrams. There's 4 statements. You have to match the statement to diagram A or diagram B? Give it a shot. So when we look at A represents increasing by 25%. So that's why number 1 and 4 can be represented with this diagram, because 25% increase is saying the same as I have 125% of. So 25% increase is the same thing as saying I have 125% of last year. So I'm comparing to last year always. On the other hand, B, that's a 25% loss. So that means, well, 3 says a 25% loss, and 2 is 75%, which is representing a 25% loss from 100. Okay. So here's practice 3. You are going to be drawing your own diagrams to represent each situation. So give it a shot. So here are the 2 diagrams. Notice that the 40% increase means I now have 140% the original, whereas the 80% decrease means I have 20% of the original. Now, we've been using our old content of unit rates, and you can still use that, but I want to see how we can now do the same thing with proportions, things that we were saving yesterday. So here's our first example. So Decathlon is trying to empty its winter stock, getting ready for spring. So a winter jacket was originally a price of $42. Whenever you hear original, or what we're comparing to at the start, you should be thinking this represents my 100%. Now we're told that it's then 25% off. So what is the new price of the jacket? Well, I could think to myself, okay, I'm setting up a proportion. What I don't have, I'm going to give a variable, and I'm going to say new price of the jacket. And I'm going to start setting up a proportion, which is our ratios that are equivalent. Now I could do this in different ways. Well, I'm saying, what is the new price of the jacket? Well, 25% off means the new price of the jacket is 75%. And well, I'm going to compare this with the original 100%. Well, I'm going to set this equal to an equivalent proportion. Well, the value of the jacket at 75% compared to the value of the jacket at 100%. Well, this is where all of a sudden I can now do cross multiplication. So I get 100x is equal to 75 times 42, which is 3,150. I then divide both sides by 100, and I get x equals 31.50. This is my new price. Well, I could have done it another way. I could have actually set it up as y represents the discount. Well, the way this would have changed is I would have had 25 over 100 equals y over 42. I still would have cross multiplied, and I would have earned 100y is equal to 42 times 25, which is 1050. I then would have divided by 100 and received 1050. Well, this is the discount. So I then have to say 42 minus 1050 and get the answer 3150. So there's different ways to get the same answer. So make sure you pause this if you need to add this to your notes. Otherwise, here's the general idea. Here's our key takeaway. When using proportions, our two ratios Over here, we have our percentages. Over here, we have the value of the topic we're talking about. On the denominator, we have the 100%. On the top, we have the additional percent looking for, increase or decrease. So here's an example, and let's think about this all together. Well, Milan recently increased the fine for parking illegally from 38 euros to 45 euros. This represents an increase of what percentage? Well, that means what I'm missing is the increase percentage. Well, that's the top part up here. So we'll say P over 100 equals, well, my 100% is always my original, so that's 38. Now, I define P as my increase, which means I just care about the increase. So 45 minus 38, that's 7. So I get 7 is my increase. Cross multiply, 700 is equal to 38P. Divide by 38. And I get P equals 700 divided by 38, about 18.42. For this, round to the hundredths if needed. That's what we're going to do. So we have an 18.42% increase. So I'm now going to go on to some practice. So you are going to be doing some practice problems, and there will be feedback afterwards. So make sure you take advantage of that feedback. All right, best of luck. So here's the answer to practice 4. Now, as you see, I define G as the increase, which means we increased 5%. Now I got the answer 4.4. You can't have 0.4 of a bird. So I have to say about 92 griffins as the final answer. Now I wanted to show you another way to solve this. A 5% increase, another way of saying that is saying I have 105% of the original. So notice that I've defined the X differently this time, and I said it's my new population because it's the 100% and the 5%. And when I solve it, I still get the same answer. I'm just going straight to the answer. If you have any questions, make sure you come into Google Meet. Otherwise, go on to your next practice problem. So here's the answer to practice 5. Now notice I did this one, 6% increase. So that therefore was 106%. You could have found 6% and then added it to 63 million. Having 0.78 of a million is an acceptable answer, so no rounding needs to happen. So let's move on to practice 6. All right, here's practice 6. So I again solve this in 2 different ways. The left side, X as the percent increase. So notice, since I'm dealing with just the increase, I wrote 302, which represents 450 minus 148. I was looking at just the increase. Now the Y was percent of the original. Well, that means I'm taking into account the 100%. So it makes sense that in the end, the value to Y is 100% more than the value to X. But when I'm talking about the increase, I don't want to take into account that 100. And so for the Y, I would have to subtract the 100% from the 304% to still get the same answer. All right. Practice number 7. Hopefully it's becoming a little easier for each question you do. So I found 14% of that 36 million. That represents what they want to reduce by. So I then had to subtract that from 36 to find out that they want in 2020 30.96 million tourists to visit Venice. Okay. Practice 8. Go ahead. So I did this as percentage of last year's air index. So I used the number 85. Now, when I got this percentage right here, that represents what it is compared to last year. Well, I want just the decrease. So I have to say the 100% minus where it is now, and therefore I get the answer 25.44% decrease is their goal. Now, again, you could have solved this in a different way. You could have set up the proportion instead, saying 29 over 114 equals, say, x over 100, where x represents the percent decrease, because I did 29, which is the decrease. So if you have any questions, make sure you come in and ask me for help. Otherwise, here is a little exit ticket for you to agree or disagree, support with 2 or 3 sentences. Let's see what you say. Have a great rest of your day, guys. Bye.